NEC Article 300 addresses wiring methods and materials. Section 300.5 specifically covers the direct burial of conductors and cables. Paragraph 300.5 done deals with underground installations. It states that conductors and cables installed underground must be listed for direct burial use, but they need to be protected by raceways, sleeves, or other suitable means listed for this purpose. The standard underground installation depth should not be less than 12 inches below the finish grade. It also must comply with 300.5 D2 through D5. There are exceptions to this 12-inch rule. Exception number 1 states that where necessary to prevent damage to existing structures or property, the burial depth can be less than 12 inches. However, in such cases, the insulation must be not less than 4 inches below the finish grade and must be protected from mechanical damage. Exception number 2 applies to areas used solely for agricultural purposes. In these areas, the burial depth of underground service cables may be less than 12 inches, but it cannot be less than 6 inches below the surface of the earth. Therefore, if there is a situation that involves the need to prevent damage to existing structures or property, the burial depth may be less than 12 inches. However, the installation shall not be less than 4 inches below finish grade and shall be protected from mechanical damage. Direct burial cable, also known as underground feeder or UF cable, is a type of electrical cable designed to be buried directly in the ground without needing additional protection like conduit. It is commonly used for various outdoor applications such as landscape lighting, powering detached garages or sheds, and running electrical circuits to other outdoor structures. Firstly, consider the construction of direct burial cable. It typically consists of insulated conductors embedded in a waterproof, sunlight-resistant outer jacket. The insulation is usually made of a durable material like cross-linked polyethylene, which provides excellent resistance to moisture, abrasion, and chemicals found in the soil. Secondly, the NEC sets specific requirements for the installation of direct burial cables to ensure safety and prevent damage to the cable. Article 300.5 of the NEC covers the requirements for underground installations. Thirdly, regarding burial depth, the NEC specifies minimum burial depths for direct burial cables based on the voltage of the circuit and the location of the installation. For example, for residential branch circuits and feeders operating at 120 volts or 240 volts, the minimum burial depth is typically 12 inches. However, there are exceptions to this rule in certain situations. One exception allows for a reduced burial depth of 4 inches in areas where the cable is protected by a 2-inch thick concrete pad or similar physical barrier. Another exception applies to installations under driveways or parking areas, where the minimum burial depth may be increased to 18 inches or more to protect the cable from vehicular traffic. Fourthly, when installing direct burial cable, it is essential to follow the manufacturer's instructions and local electrical codes. Before digging, always call the local utility companies to locate any underground utilities in the area. This will help prevent accidental damage to buried lines and ensure your safety. Fifthly, dig a trench that is deep enough to meet the minimum burial depth requirements. The trench should be wide enough to accommodate the cable without putting undue stress on it. Remove any rocks, roots, or other debris from the trench that could damage the cable. Sixthly, unroll the cable and lay it in the trench, making sure to leave some slack to allow for soil settling and temperature changes. Avoid stretching the cable tightly, as this can damage the insulation and conductors. Seventhly, backfill the trench with clean soil, free of rocks or sharp objects. Tamp the soil firmly around the cable to provide support and prevent it from shifting. Eighthly, when connecting the direct burial cable to electrical equipment, use waterproof connectors and fittings that are specifically designed for underground use. These connectors will protect the connections from moisture and corrosion. Ninthly, consider marking the location of the direct burial cable with underground warning tape. This tape is typically buried a few inches above the cable and will alert anyone digging in the area to the presence of the buried cable. Tenthly, after completing the installation, test the circuit to ensure that it is working properly. Use a multimeter to check the voltage and continuity of the circuit. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation and testing. 11thly, remember that direct burial cable is designed to withstand the harsh conditions of underground environments, but it is not indestructible. Over time, the cable can be damaged by moisture, chemicals, rodents, and other factors. Regularly inspect the cable and connections for any signs of damage, such as cracks, cuts, or corrosion. If you find any damage, repair or replace the cable immediately to prevent electrical hazards. 12thly, when selecting direct burial cable, choose a cable that is appropriate for the specific application. Consider the voltage and amperage requirements of the circuit as well as the environmental conditions in the area. Use a cable that is rated for direct burial and is resistant to moisture, sunlight, and chemicals. 13thly, direct burial cable is a versatile and reliable wiring method for outdoor electrical installations. By following the NEC requirements and proper installation techniques, one can ensure a safe and long-lasting electrical system. Consider the specific types of direct burial cables that are commonly used. USB cable, or underground feeder and branch circuit cable, is one of the most common types of direct burial cable. It consists of individually insulated conductors surrounded by a grey outer jacket. USB cable is suitable for direct burial in soil and is resistant to moisture, chemicals, and sunlight. Use cable, or underground service entrance cable, is another type of direct burial cable that is commonly used for underground service entrances. It has a similar construction to USB cable, but is designed to handle higher voltages and currents. Use cable is typically used to connect the electrical service from the utility pole or transformer to the building's electrical panel. Consider also direct burial low voltage lighting cable. This type of cable is specifically designed for low voltage landscape lighting systems. It typically consists of 2 or more insulated conductors surrounded by a black outer jacket. Direct burial low voltage lighting cable is suitable for direct burial in soil and is resistant to moisture and sunlight. When installing direct burial low voltage lighting cable, it is important to use connectors and fittings that are specifically designed for low voltage applications. These connectors will ensure a secure and reliable connection and prevent moisture from entering the system. When working with direct burial cable, it is also important to follow certain safety precautions. Always disconnect the power to the circuit before working on any electrical wiring. Wear appropriate personal protective equipment, such as gloves and safety glasses. Use insulated tools to prevent electric shock. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation. One should never bury electrical cables in areas where they could be damaged by digging or other activities. Avoid burying cables under driveways, sidewalks, or other paved surfaces. If it is necessary to bury cables in these areas, protect them with conduit or other physical barriers. Also, be aware of the potential for soil conditions to affect the lifespan of direct burial cables. Acidic or alkaline soils can corrode the cable's outer jacket and insulation, leading to premature failure. If the soil in the area is known to be corrosive, consider using a cable with a more durable outer jacket or wrapping the cable in a protective sleeve. Rodents can also damage direct burial cables by gnawing on the outer jacket and insulation. To prevent rodent damage, consider using a cable with a rodent-resistant outer jacket or burying the cable in a conduit. Finally, remember that the NEC is updated every 3 years, so it is important to stay up to date on the latest requirements for direct burial installations. Consult the latest edition of the NEC and local electrical codes to ensure that your installation is safe and compliant. The NEC provides a comprehensive set of guidelines for the safe and effective installation of direct burial cables. By following these guidelines and using proper installation techniques, one can ensure a reliable and long-lasting electrical system for outdoor applications. Additionally, when installing direct burial cables, one should consider the impact on the surrounding environment. Avoid disturbing vegetation or wildlife habitats as much as possible. Use trenching methods that minimize soil erosion and runoff. Dispose of any waste materials properly. One can also choose to use environmentally friendly direct burial cables that are made from recycled materials or that have a reduced environmental impact. These cables can help to reduce the carbon footprint of the electrical system and promote sustainability. In addition to the NEC requirements, there may be local regulations or ordinances that govern the installation of direct burial cables. Check with the local building department or electrical inspector to ensure that the installation complies with all applicable codes and regulations. When planning a direct burial installation, it is important to consider the future needs of the electrical system. Design the system to accommodate future expansion or modifications. Use larger sized cables than are currently needed to allow for increased loads in the future. Install spare conduits or raceways to facilitate future cable installations. Finally, remember that direct burial cables are a permanent part of the electrical system. It is important to keep accurate records of the installation, including the location of the cables, the type of cable used, and the date of installation. These records will be helpful for future maintenance and repairs.